Hey guys, welcome back. Naj Kazi here. First of all, I wish you a very happy 2022. Second, I've got a great video for you here today. Today's video is all about network automation. We're gonna do a deep dive. I'm gonna walk you through terms like REST API, CRUD, HTTP verbs, URIs, things like data serialization, and also deserialization. What does that actually mean? Standardized formatting. I'll then provide an overview of JSON. I will then take a step back and walk you through DevOps or net DevOps. These two terms are interchangeable depending on the text you read. Mostly in the Cisco realm, you're gonna hear the term net DevOps. And finally, I'll wrap it up with an overview of network configuration management automation tools like Ansible, Chef, and Puppet. This is going to be a very exciting video, and by the way, this is the last video in the CCNA series. So have fun, and I wish you the best of luck in your CCNA journey. That said, let's roll. Welcome to CCNA 200-301 course. Today is the final video of the CCNA series. I'm very excited about that. Section 6, Part 2. Today's session is a deep dive in network automation. Here are the topics I plan on covering today. First, REST API overview. Second, data serialization and JSON overview. Third, DevOps overview. Finally, I'll wrap it up with an overview of configuration management tools such as Ansible, Chef, and Puppet. Let's go. First, let me start off with a REST API overview. Now that said, in my previous video, I went really deep into this, so here I'm just going to provide a very high-level overview. So if we look at an SDN controller, which becomes the central management point of our entire network, there's a couple of terms that you need to understand. First, what does an API stand for? Application Programming Interface. Now, an SDN controller has northbound APIs and southbound APIs. When it comes to southbound APIs, these are the APIs that speak to the south of the SDN controller. Network devices like routers, switches, firewalls, load balancers, you name it. Any network appliance that is managed by the SDN controller is a fair game here. And it uses protocols like OpenFlow, which is an open standard protocol, or OpFlex, which is Cisco proprietary. It uses SSH, SNMP. It could use netconf or a combination of all to provision the network, to monitor the network, to configure the network. Basically, everything we did in the past with CLI and a lot more can now be done using the SDN controller through GUI and using APIs. And from a northbound perspective, what we have is a northbound API. And typically, northbound APIs use RESTful or REST APIs and sometimes Java APIs. And the whole idea here, guys, is if I have a browser on my laptop, for example, I can connect to the SDN controller. And when I do, using my browser, I'm actually using a northbound API to speak HTTPS, for example, and have GUI access into the controller. This is a very rudimentary form of a northbound API. But if you want to take this to the next level, is we can use third-party automation tools like Ansible, Chef, Puppet. These three I'll cover later in this video today. But the idea is that I can use applications on the northbound to be able to program my network intelligently and in an automated fashion. Now, a couple of additional terms, because with APIs, it's very important to have a really good grasp of the terminology. For the rest of the information to sink in, you gotta understand the terminology. So there's this term called CRUD. It comes from the software development realm, and it stands for, the C in CRUD stands for create, R stands for read, U stands for update, and D stands for delete. And it's directly related to the HTTP verbs that we can use to be able to manipulate data that we would like to manipulate. And there's also a function that's attached to each. So let me explain. So the term create in CRUD equates to post in HTTP, which actually means create a URI. You can think of a URI as an object. So basically what we're saying when we post something to HTTP is we are basically creating an object. When we say HTTP GET, we say we're reading an object. When we say HTTP PUT, we're saying we're updating an object. And when we say HTTP delete, that means we're deleting an object. So that's what the term CRUD stands for. There are a lot more HTTP verbs than these four, but just to simplify things, I think these four are the most fundamental and crucial for you to understand before you get into more advanced level stuff. Now, some conceptual level understanding of HTTP verb and URI. So if you were to look into a packet that actually has HTTP verbs and URIs contained within it, when we zoom into it and we look at the headers of that packet, we're going to see the layer 3 header, the layer 4 header, and then the rest of the information. Now, when we zoom into the HTTP side of the house, what we'll see is we have HTTP request header and then we have HTTP other headers. Now, typically the verb, HTTP verbs we just looked at are contained within the HTTP request header. Also, the URI or the object is also contained within the HTTP request header. However, the API parameters, like, whatever we're trying to update or delete or any type of parameters that we pass through the API are contained and located within the HTTP other headers. Now, if you were to look at, for example, a request called HTTP GET URI. So what does GET mean in HTTP? So if you guys recall, the previous chart we were looking at, GET means to read. So here I'm saying HTTP, go ahead and read me an object. And what object is that? It's a URI 2. Now, what does that mean? So I actually have a REST server, which in this case could very well be the SDN controller. And it's got different URIs stored on it. So URI 1 will have a resource and variables attached to that resource. URI 2, resource variables. URI 3, resource variables, so on and so forth. Now in this request, I'm very specifically asking for URI 2, which in this instance could be, hey, I want to go ahead and get a read on all the live interfaces on this router. And with this request, that's exactly what I'm going to get back from the HTTP REST server, which in this case, like I said, could very well be the SDN controller. Now, kind of zooming into it a little bit more, typically when we're using an API to manipulate things, either we're going to be doing things through a GUI or we're going to have some sort of a configuration management tool that allows us to create scripts and run scripts against the northbound API. So what is a URI? So here I'm going to give you a more in-depth view of a URI. So if you look at a typical URI, it looks like a URL almost, like the URL you guys are familiar with, right? Which is a uniform resource locator. When you go to a website and you go to a certain page, the complete address is called a URL. And in this case, in URI, it's very similar to a URL. We have a protocol, which in this case is HTTPS over port 443. We have a server URL, so in this case it's NOJ DNAC. DNAC stands for DNA controller, which I talked about in my previous video. And then finally, the part in green is the resource path of where that resource is located. Now, the entire structure that I'm showing you here is called a URI structure. This entire thing is a URI. And to take it a step further, what we have here is, once again, we got the protocol, we got the server URL, we got the resource path, but what we have in addition to that is a certain parameter. It could be a set of parameters too, or it could just be a one parameter that we are passing through the URI against the API in order for us to be able to either read something or write something. And our SDN controller is able to understand the request and get us the information we're looking for. Now let's shift our attention to data serialization, and I'm also going to provide a quick overview of JSON. So what is data serialization? Let me explain. So we have a data object. Typically that's complex data. And the idea of data serialization is we want to take that data object that we have stored on our computer, and we want to convert it into a stream of bytes. And why would we want to convert that object into a stream of bytes? Well, we want to allow that data to be stored and transferred and distributed, right? So this is where file, database, memory comes in. And then from those resources, we take that stream of bytes and we convert it back into an object on the destination end. This entire path from left to right is called data serialization. So let me give you an official definition of data serialization. It's a process of converting complex data into a byte stream for storage, transfer, and distribution purposes on physical devices. So if you think about it, guys, different computer systems and environments have their own proprietary data format. So if you look at Microsoft Windows, it has its own proprietary stuff. And if you look at Apple Macintosh, it has its own proprietary stuff. And if you look at Linux, it's got its own stuff. And how do we allow the data to be able to talk to each other and these different systems to be able to understand the different type of files and data objects? Well, that's where data serialization comes into play. And what it does is it turns a traditional proprietary data format on its head by storing and exchanging data into a standard format that is platform and language neutral and can be understood universally. So in other words, the stream of bytes has to be standardized format, and that's what allows us to make this data portable. So as you go from Microsoft Windows to Linux to Mac, you have this consistent standardized data set that looks the same and functions the same. And a couple of additional terms that are related to data serialization. There's a term called deserialization, and it's the opposite of serialization. So here what we're doing is we're creating an object from a stream of bytes. And some additional terms as you read through different text, different books, you're going to come across could potentially be data serialization language. It's also known as data modeling language. And by the way, JSON belongs to a standardized format. So does XML. But today I'm going to focus in on the JSON format, which is a data serialization format. JSON stands for JavaScript Object Notation. It's one of the most popular data formats for dealing with web APIs because, first, it's an IETF standard defined in RFC 8259, which makes it widely adopted globally because it's an open standard. It's human readable, which makes it very easy to understand and learn. It requires less coding, which means you don't have to be an expert software developer to write JSON scripts. And JSON processes faster on machines. So whether you're using a $10,000 desktop machine versus a $500 cell phone, it's going to get processed very fast and very efficiently. REST or RESTful APIs mostly use JSON, and that's what makes JSON so popular as well. And to understand JSON, the big thing with understanding any data format is to understand the different data types that are supported by it. So if you guys have any software development background, you will understand what the different data types mean. And even if you don't, just hang in there with me, you'll get it as I go into the detail. So the first type is string, second number, Boolean, null, object, and array. These are the 6 data types that JSON supports. And before I get into the data types, let's quickly look at Ferrari Enzo. And one thing I want you guys to familiarize yourself with is there's this whole idea in JSON called key value pair. So here we're saying, who is the manufacturer or the maker of this car? Well, obviously it's Ferrari. So what I'm saying is this is the key and this is the value. Like I said, it's the key value pair idea. Well, what's the model? It's an Enzo. What year? 2004. Color, red. Price, forget about it. Because it is very ridiculously priced. As a matter of fact, quick tidbit, Ferrari only produced Enzo between 2001 and 2004. And there's only a handful of these globally, and they're only appreciating in value more than real estate. I think the last one sold in an auction was $3.6 or $3.8 million or some ridiculous number like that. But that's not the point. I digress. The point is that we have this key value pair idea in JSON. So maker would become a key. Ferrari would become a value. Model would become a key. Enzo will become a value. Year would become a key. 2004 would be a value. Color would become a key. Red will become a value, so on and so forth. You get the idea. And this is what the entire structure is based around when you learn JSON. Once you get this idea in your head, the rest is simple. But this is the big idea, key value pair. Now let's get into the data types. So the first type of JSON data type that I want to bring to your attention is string. String in JSON is a sequence of alphanumeric characters. So here's a sample code. Now, a couple of things I want to bring to your attention here. See, in this sample code, I have the curly brackets. This is the starting bracket. This is the ending bracket. And these are curly brackets. Then space, then we have double quotation marks, and we have a word maker. Then we have a colon, then we have a space, and by the way, we don't need to have this additional space here, but I did it for clarity. Then double quotes again, and the term Ferrari. Now, once again, what is the term maker? This is the key, and what's the value for that key? Is Ferrari, okay? So whenever you're reading a JSON code, you're always going to see that it starts off with a curly bracket. It ends with a curly bracket. And in between, you have key value pair. Here, we're looking at a string data type. Now, based on this understanding and logic, I'm going to continue building on it and explain other data types. The next data type is number. JSON uses JavaScript's double precision floating point format. What does that mean? Here's a sample code. Start of curly bracket, space. Once again, we don't need a space, but I'm adding a space to make it look neat. And by the way, spaces don't matter. White space, I should say, does not matter in JSON. So that's important for you to understand, because in some programming languages, adding space is a major sin. In JSON, that is not the case. So to read the sample code here, once again, we have starting curly bracket, ending curly bracket. In between, we have two bids, bid 1 and bid 2. The first bid, bid underscore 1, I have a colon and then space and number 100. Now notice there is no double quotes around number. We do not put quotes around numbers. Once again, this is key value. Key is the bid is the key, and 100 or bid underscore 1 is the key. 100 is the value. And then bid 2 or bid underscore 2 is once again a key, and 100.99 is the value. And also notice between bid 1 and bid 2, I've got a comma and then space, and then the next string, so to speak, and then the next key value pair. So you see, when to separate key value pairs, what we have to do is we have to have a comma in between different key value pairs. Now let's look at Boolean. Boolean is basically binary. What that means is you only have two possible values. It's either true or false. And Boolean is treated as string values. So here's a sample code. We're saying, is it Ferrari? Of course it is. So it's true. But if it said, is it BMW? We would have said false. You get the idea. The next one is null. Null is essentially an empty value. So what does the code look like? It's saying, is it Roma? We're saying it's null, meaning it's not Ferrari Roma. Roma is a completely different model of Ferrari. We're looking at Enzo. So it's a null. Some additional data types. Now, object, it's an unordered set of key value pairs separated by a colon, like I explained earlier, contained within curly brackets. The values must be unique strings separated by comma. So here's a sample code. An engineer, and that engineer has a name, Naj, company that this engineer works for, WWT, and the city this engineer lives in is San Jose. Now, a couple of things I want to bring to your attention. This is the start curly bracket. This is the ending curly bracket. What about this curly bracket? Well, notice we have another starting curly bracket and an ending curly bracket. Here, this is an object. Engineer is an object that has multiple attributes within it. So a name is an attribute, a company is an attribute, a city is an attribute, but that all of these are contained within the object called engineer. So what we're doing here is we're basically defining an object. As I said earlier, white space doesn't matter. So what you would do is you would typically take, instead of writing the entire code on a single line, what you can do as best practice is to add white space. And what that does for you is brings more clarity. So as you can see, the same code here, again, provides a lot more clarity to what we're trying to achieve here. So here, once again, the object is engineer, and contained within that object are different attributes, which are string values, essentially, because we just learned strings. And it's defining that object. Now, a couple of things I want to bring to your attention from the white space standpoint is, once again, we have double quotes around engineer, we got a colon, then we got space, and then the curly bracket. And as you can see, for each string, there's a comma in the end. That's another string, and there's a comma in the end. But check this out. The third one, there's no comma, because this is the final string that defines our object called engineer. So because this is final, we're ending it with a curly bracket, which started right here, and we're ending it right here. Okay? So this is very important to notice. For exam and also for real-world purposes, there is no comma at the end. So definitely keep that in mind. And by the way, to verify your code that you wrote, ideally what you should do is go and Google the term JSON validator. And what that will do for you is help you validate the code that you wrote. As a matter of fact, let me show you what I'm talking about. Let me look up JSON validator. And I'm just going to go ahead and click on the first option that's available to me. So let me go ahead and run a JSON validator against the code that I showed you a moment ago. And look what it did. First of all, it gave me a confirmation down here at the bottom that it's a valid JSON code, which is beautiful, right? So this is great. And also see what it did to my code. Even though I wrote the code in one line, it beautified my code by adding white space to my code to make it easier to understand. So once again, you see the object engineer, and that object has all these strings. And as I said, there's no comma in the end. To prove my point, I'm going to go ahead and add the comma and hit validate JSON code again. And check this out. It's saying there's an error on line 5. And we know what the error is because we added the extra comma on this line. In other words, this validator is pointing us in the right direction. It's telling us there's something wrong with this line. And by paying close attention to it, we can fix the problem. So if I were to remove the comma again, hit validate JSON, once again, it's telling me it's a valid JSON code. So I encourage you to get into the habit of using a JSON validator as you practice writing JSON code to ensure you're actually writing good code that is bug-free. Now, the final data type, and this one is a very important one, is an array. An array is an ordered set of key value pairs separated by a colon. However, the difference between an object and an array is contained within square brackets instead of curly brackets. And I'll show you some sample codes to hit this point home. The values must be JSON supported data types. And so what are the data types? Well, string, number, Boolean, null, object, or array. Now, what's interesting is you might be going, isn't this an array? How could you have an array within an array? Well, that's a mind twister, I know, but that's the idea. An array is a very comprehensive data type that pretty much contains all the other data types, and it has the ability to have nested arrays and nested objects within it. So it allows for a very complex data type that has a lot of objects and arrays within it. So a sample code could be CIS students or computer information systems students. So here I'm showing student name Bob, age 28, employer is WWT, then comma, another student named Dan, age 31, employer Facebook. Now let me add some white space to this code to make it easier for you to understand, and let me bring a couple of things to your attention. So look, here we're starting at CIS students, and then we have a colon, and then check this out, we have a square bracket followed by a curly bracket. And then we have the first student, Bob, age 28, employer WWT. And then we have the ending curly bracket. Then we have a comma. And then we have a starting curly bracket for the second student. So student is Dan, age 31, employer Facebook. And then we have the ending curly bracket. And then we have the ending square bracket. And then we have the ending curly bracket to end the entire code. So as you can see, here we're showing computer information system students, let's say in a college or a university, and different attributes associated with each student in that course. Now let me show you another sample code. So here the student name is Bob, age 28, classes, Comp 101, Soft 101, Net 101, Employed, False, Employer, Null. Let me add white space to it, and let me give you a quick walkthrough of this code. So here I'm saying I have a student name, Bob, age 28. Classes that this student is taking, Comp 101, Soft 101, Net 101. This student is not employed, employment is false, and employer is null. Because they're not employed, so of course there's no employer to report. Now, one interesting thing about this example for you guys is, check this out. We have all the different data types covered here. We got the string data type. We got the number data type. We got an array here. We got the Boolean data type. And then we also got the null data type. Moving on. Now let's shift our attention to DevOps. So what is DevOps? Now I touched base on it in my last video as well, but here I'm gonna go slightly more in depth. Now, just to set proper expectations, DevOps is not really part of CCNA. This is more of an advanced concept. It's only highlighted at a very high level in the exam, but I think it's a very real world topic right now and very important for you to understand as a network engineer, because today's network engineering is all about DevOps and you must understand what that means. So what does it stand for? Well, it comes from two different terms. Software development, that's the dev piece of it, and network operations, that's the ops in the DevOps. So when we combine the two together, we get the term DevOps. Now, you might be scratching your head thinking, software development and network operations are two completely opposite ends of the spectrum. So what are we trying to do here? Well, let me explain what has transpired over the past decade, especially over the past half a decade or so, that has accelerated the trend of adopting the DevOps movement. So first, let me take a step back and give you the official definition of DevOps. It's a discipline of applying software development agile methodology principles to networking. So for those of us that are familiar with agile type project management approach, agile methodology is basically we do projects in sprints and we do them at a very, very rapid pace. Sprints are basically the amount of time that each sprint might be made up of. So for example, you may have sprint 1 that is 2 weeks long. And then you have another sprint, sprint 2, that is another 2 weeks. So by defining different sprints, you're breaking the project into smaller chunks and smaller pieces, hence achieving the ability to have a lot of agility. This is where the name agile methodology comes from. Okay, so that's the first definition of DevOps. The second definition of DevOps, and I'm using another term here, which is also interchangeably used with DevOps, is called Net DevOps. And here the net stands for network, of course. So Net DevOps is a practice that facilitates collaboration between the network design and network operations teams in order to automate the process of network design and changes. So what the second definition is saying is we have evolved. So remember how we used to be cavemen and then fast forward 21st century and we're now living in a metaverse. Similarly, we used to do things by hand. Now things are changing. Now we need to automate because there's a proliferation of technology, new IoT devices, new hacking attacks, and with new demands, we have to have a new type of methodology of doing things. So Net DevOps encourages network designers or architects to work very closely with network ops teams that are traditionally used to just managing and monitoring networks to create a automated workflow for network provisioning and for network changes. What that eventually leads to is what we call infrastructure as code. It's a buzzword, and you may also hear some other terms that are interchangeably used with infrastructure as code. Terms like programmable infrastructure and software-defined infrastructure. Now, the agile methodology in DevOps introduces what's called CI/CD pipeline, which is a catalyst for automation. So what does CI/CD stand for? Stands for continuous integration, continuous delivery. And sometimes the CD could also be called continuous deployment. Now, the continuous delivery is a more preliminary step. Continuous deployment is for organizations that are more mature on the DevOps spectrum. The whole idea is that we treat our entire network from start to finish as a pipeline. So now let me zoom into the DevOps framework. So here, once again, like I said, we're bringing the development team and the network operations team together. So what happens is, the first thing that happens is the development team comes up with a game plan. They think of or conceive of an application they want to design. So they go through the planning phase. Once they have determined what they want to do, there are dedicated engineers and teams that start writing that software code. And what I mean by build is that they either build the code from scratch or they integrate the code into the existing code that's already written. So for example, if you're adding a new module to an existing application, you would integrate code, but you may very well be starting from scratch. After all these steps, you would want to test them to ensure that the code is valid and bug-free. And then at that point, a handoff happens to the operations team. And this is where the release comes in. Then you release the code into the wild, but you do it in a very smart fashion. Typically, you go from test to a dev environment or quality assurance environment. From there, you deploy the code, and at that point, the code is now deployed into the production network. And then you operate the network at that point, and you monitor. You see the changes that you introduced into the network, whether or not they had a positive or negative impact. And as you can see here, it's a continuous loop. It's a self-perpetuating continuous loop of changes. From monitoring, you go back to square one again, you look at what else needs to be done to continuously enhance the security of the network, to continuously introduce new features and functions into the network, to add more stability to the network. You go back to planning, you code, you build, you test, you release, you deploy, you operate, you monitor. So you get the idea. It's a continuous loop, and it's a never-ending infinite loop. Hence the reason for the infinity symbol here is that it's just a continuous cycle. And to give you another perspective, typically when you write the code, you test it. And what you would typically do is you would create a bunch of virtual machines or containers to set up a test environment. From test, you will go into your dev environment. It's also known as quality assurance environment. It just depends on the organization, the terminology used. But the idea that the big difference between test and development environment is that development environment mimics the production environment very closely. So test may not have anything production related at all, but dev is an exact replica of the production. But the difference is there's no production devices plugged into this. It's just a replica to ensure that if the code was to be released into the production environment, it's going to function as intended. And then once you're 100% confident that your code didn't cause any issues in the development or the quality assurance environment, is that you're going to have the ability to go ahead and launch that code into the production environment. And this is where CI/CD pipeline comes into the picture. As you can see, this whole entire thing is a pipeline. As we go from test to dev, from dev to prod, it's a pipeline. And each element within the pipeline, we can go ahead and automate. So we can write scripts to spin up VMs and containers to quickly set the test environment. We can do the same thing in the dev environment. And finally, the code gets released and deployed into the production environment. And that said, deployment is where we're going to focus next. This is where the automation tools or the network configuration tools come into play. Things like Ansible, Chef, Puppet, they live right here. Let's get into that next. But before I do though, I think it's important to let's take a step back and look at how we got here and what led to the whole DevOps mindset. And by the way, DevOps is not as easy as just sending a bunch of your team members to take a DevOps certification class, and after they get certified, all of a sudden, magically, your organization is now DevOps organization. It doesn't work this way. What it is it's a cultural change. It's a cultural shift in the way your organization operates and functions. The organizations today have a culture of fear. What that means is changes happen rarely in our network. Changes are big and complicated in our network today. Teams aren't well prepared and practiced to handle changes. Changes are seen as high risk. Problems occur as changes are introduced. Think all the weekends and late nights after business hours that engineers and teams have to spend for changes to be pushed. And changes are seen as failure. So if you are a traditional network engineer, if you are making a ton of changes to your network every year, you're going to get dinged on your annual review with your boss. And most likely you're going to get fired for making changes because changes are considered bad in the legacy or a traditional network engineering mindset. But that's a culture of fear, right? The leadership, the way they design the whole culture is to eliminate and reduce the number of changes. But that's not the fact of life today. If you look at your phone or your iPad or Android, one thing you'll see is almost on daily basis, there are app updates that are being released to make the apps better, faster, more stable, more secure. Similarly, organizations need to be on the cutting edge to have a competitive edge in the marketplace, and they need to adopt change. And this is where net DevOps come into play. So with net DevOps, the mindset is changes are part of life. Each change is small. Team is well practiced because that's all they do. They write code, scripts, things of that nature. You test the heck out of those changes in a test and dev environment, like I alluded to on the last slide. Change is typically uneventful because you already tested it and you verified it in your quality assurance phase. So you know there's going to be zero impact to the environment. And changes are actually rewarded. It's considered a success. So the more changes you make as a net DevOps engineer, the more praise you're going to get from your leadership. You're going to probably get a bonus, a promotion. You're going to be rewarded for more changes. So you see the difference. The difference is a 180-degree shift in how the organizations operate. So now, as you can see, it's not just a change at a network engineering level, but it's a change at a leadership level in the organization to change the company from a culture of fear to a culture of change that embraces change and thrives in the 21st century. Now let's shift our attention to configuration management tools. I'm going to provide a quick overview. The first tool I want to look at is Ansible. Now, Ansible is an agentless network automation tool. It's an open source tool, so that automatically means it has a free version available, but it also has paid versions for enterprises. Now, you may ask yourself, why would I want to pay for this service as an enterprise? Well, trust me, you do. Because when you have a paid version, you have a bunch of engineers that are available to you in case you run into any issues. You can contact them via phone or they're just an email away. So you want to have access to those support resources if you run into issues. Now, Ansible server can be installed on a Mac or Linux, and it uses a push model. And what that means is Ansible doesn't rely on any code or agent running on the network devices. The code actually runs on the Ansible server, and configs can only be pushed to the network devices via the Ansible server using SSH or netconf. So it's a one-way change that gets pushed to the devices from the server to the devices in that direction. Now, Ansible server contains some text files. Once you're done installing the Ansible server, there's a couple of text files that you need to be aware of. The first one is called playbooks. It's a master instruction file with step-by-step tasks. There's also another file called inventory file. It's a list of all the network devices in the network. Then there's templates. It's a baseline config with variables using Jinja 2 language. And finally, there's a variables file. It's a list of variables that Ansible will substitute into the templates using YAML. And YAML stands for YAML Ain't Markup Language, which I find hilarious. Somebody got really cute with the name here. And now here's a visual view of what I explained so far. So we have an Ansible server, could be a VM or a container or whatever have you. We have an inventory file, we have templates, we got variable, we got all these files that are subset of the playbook. And then what we do is we run that playbook via SSH or netconf and we log into the router or switch, or in this case, it's a router. And by running that playbook, we're pushing a certain configuration to that device. Now let's shift our attention to Chef. That's another very popular network configuration tool. It's an agent-based network automation tool, and it uses a client-server model. It's open source, so once again, it has both paid and free versions, and I explained earlier why you would want to be on a paid version if you're doing this in a production environment. Chef can be installed on a Mac, Linux, or Windows. It uses a pull model, so this is the opposite of the Ansible. Here we're pulling information. So the idea here is each managed network device runs an agent called Chef node or a Chef client. So managed device is basically a client. Router, switch, firewall, you name it. An agent monitors and compares its configuration against the configs available on the Chef server and automatically synchronizes the configuration if it finds itself to be out of compliance. And here are a couple of text files that are contained after you're done installing the Chef server. You have a file called recipe. This is the master instruction file with step-by-step tasks. The next one is cookbook. It's a list of all similar recipes grouped together. Another one is called run list. It's an ordered list of recipes for a given network device. And finally, there's a text file called resource, the config objects whose state is managed by Chef. So let me quickly give you an overview of how it looks like visually. So you have a Chef server, which could be installed as a VM. You have a resource file, and then you have a recipe or run list, and the resource is a subset of that. And what a Chef node in this case would do, which is a client essentially, is it would actually pull details from the Chef server. And when it finds that it doesn't have the information that is expected to have, it goes ahead and pulls that configuration. So the onus is actually on the network client to be able to pull its configuration, compared to Ansible, where the change was pushed from the server in the direction of the client. Here, the client is asking for information from the server. But the big difference here is that you need to have a client, a little piece of software. It's a very lightweight software running on your network endpoint. Now, one big thing to keep in mind is not all network endpoints are created equal, so they do not have the ability, some network endpoints, to actually have a client installed or an agent installed. So you have to be very careful when you're deciding on using the appropriate tool chain for doing network automation. Make sure you're picking the right solution for your environment. In other words, if you have a lot of old Cisco gear in your network that you're not planning on replacing anytime soon, then you should probably look at Ansible instead of Chef. Because most likely the network devices you have in your network today, if they're older switches or routers, they may not have the ability to install an agent on them. So you're going to have to rely on something like Ansible to be able to push configs. Something to keep in mind from a real-world perspective. And finally, we're going to look at Puppet. This is another very popular network automation tool. Once again, very similar to Chef. It's an agent-based tool, client-server model. It's open source like the rest. It has both free and paid versions available. Puppet Server, also known as Puppet Master, can be installed on a Linux or Windows. It also uses a pull model, very similar to Chef. Each managed network device runs an agent called Puppet Agent. An agent monitors and compares its configuration against the config available on the Puppet server, and when it finds itself out of compliance, it automatically synchronizes itself by pulling the config. Now, once you're done installing the Puppet Master or the Puppet server, it contains the following text files. It has what's called a manifest. This is the master instruction file, and it contains what's called the desired end state of the network endpoint or Puppet agents. And then it has another text file called resource or class or module. Typically, these terms refer to manifest components, with module being the largest component. And then within module, we have different classes. And then within classes, we have resources. And finally, we have templates. It's a baseline config used to generate manifests by substituting variables into the template. Here is how Puppet works. We have a Puppet Master, which is a Puppet server installed as a VM. We have templates and variables, which are basically a subset of the manifest. And then we have a Puppet Agent. Puppet Agent pulls details from the manifest to compare the config that it has against the desired state defined in the manifest. If it finds itself to be out of compliance, meaning it finds out that it's not complying to what the end state is defined in the manifest, it goes ahead and pulls the config. Once again, the onus is on the agent, not the server, to pull the configs. And finally, how do they compare and contrast? I'm glad you asked. This chart right here provides clarity on how they all operate. First, looking at the master file, right? So Ansible has playbook. Chef, it's called manifest. Puppet, it's called recipe or a run list. The protocol required on the network device, in Ansible, it's SSH and netconf. In the case of Chef and Puppet, we rely on HTTP, which basically means we're relying on the northbound APIs. Now, Ansible is agentless. We don't need to run a piece of code on the endpoints, whereas Chef and Puppet both require an agent to be ran. Now, that said, I want to let you know that at a CCNA level, this information applies, but at CCNP, CCIE, and beyond, and from a real-world perspective, both Chef and Puppet have standalone agentless solutions as well, but they are a lot more kludgy to implement and not very popular. Typically for an agentless, Ansible is the most popular solution out there. And finally, Ansible is a push model, meaning information gets pushed from the server down to the client. Whereas both Chef and Puppet, it's a pull model where the client or an agent running on the end point is responsible for pulling the config to ensure it's in compliance. And that wraps up the CCNA course. And always remember, in this class, the ultimate goal, the ultimate prize is to become CCNA certified. May the force be with you. Hope you enjoyed today's video. If you did, give me a thumbs up, hit subscribe, and I'll see you in the next video.